So let's take a deeper look at the object-oriented programming using another example. In this example, first we need to create a new pizza type, which has the following entries. I already defined this. It's relatively simple. Once we have this pizza type, we need to create a class pizza sales bar chart, which inherits from store sales bar chart. Then we need to create a double add pizza sales. Based on the pizza type, we provide a sales value to the sales amount. Then create your own version of store sales bar chart, set daily sales. This method should create a pizza sales bar chart instance, generate a random pizza type 10 times for each pizza type from this list. We will call add a pizza shop for each pizza type, then return the pizza sales bar chart instance. Note here, although we said we are going to generate a pizza sales bar chart instance and it will be returned, the return value is still store sales bar chart. It's going to be the same signature as the superclass method, which means it's overriding. And because it's overriding, note here, it's store sales bar chart, the superclass type, not the subclass type. Then in Joe's Pizza's main method, instead of, for some of the sales, instead of calling the superclass version of set daily sales, we will call the subclass version of daily sales. And I think I make one mistake. Here it should be a void because you are simply adding a price, adding a sales value to the total sales in the class. Okay, so first of all, we have the pizza type first in the enumeration. Then here we have the store sales bar chart where the pizza sales bar chart, which extends store sales bar chart, where you have the add pizza sales. Now, this is how you can generate if branches based on enumerate type. You can use a pizza type variable, test whether they are equals to or not. You can also use a switch. This is how, when you determine the pizza type, you can add store sales based on a certain value. Then we also have this set daily sales overriding, where you still use the same store sales bar chart return type, but in reality, you are generating a pizza sales bar chart instance. So, but because pizza sales bar chart is a subclass of store sales bar chart, we can actually return this instance and the Java virtual machine will still accept it. Now, inside here, we are still doing a 10-time loop. The difference is this time we are going to get a random of number 4 because you cannot generate a random number of enumeration. You cannot generate a random enumeration number. That's when you can use this integer to pizza type mapping. And each time you will just add, based on the random number generated, you will add pizza sales based on the type. So these are the methods we created based on the requirement. There's also one addition, which is a constructor I created. Now let's say if I comment out this type, this constructor, what will happen? There's an error. The error says, implicit super constructor is defined for default constructor. And the default constructor, the second constructor here in this error message, the default constructor means the default constructor of the pizza sales bar chart, the subclass. What this says is a subclass constructor. Subclass does not have a default, does not have a constructor defined. So it will be using the default constructor, which is a no-arg constructor. The no-arg constructor will call the no-arg constructor of the superclass. but this one is not defined. In the superclass, we only have one constructor, which is a constructor with argument of a name. That basically, when we define this way, we are basically saying all the constructor, all the instance created has to have a name. But this will cause trouble here because then we do not have a non-arg superclass constructor for the default constructor to call. In order to resolve this, you have to explicitly specify a constructor here, a constructor with argument, and calls the super constructor. Let me comment this out. What will happen? It will be the same error. There's no such thing as the implicit no-arg constructor. So you have to use the defined constructor of superclass. And this basically ensures the data integrity, the object integrity, because your superclass, by defining only one constructor with a store name, a sales name argument, basically is saying we do need a name for each and every instance. And Java makes sure this rule can be enforced even in subclass. If the superclass only have one constructor with name, with a parameter, then the subclass must implement it the same way. So this is how we define this pizza sales bar chart. And let's save it. Now let's go to Joe's Pizza Shop. And still the same code. I only change the first 4 store sales. You can see pizza shop, pizza, pizza, pizza. And the last 3 are store sales, store sales, store sales. And all of them, note here, all of them are defined as store sales bar chart. Although this pizza sales bar chart's set daily sales method will return a pizza sales bar chart object. That one is packaged as a store sales bar chart. So let's run this now. It's asking me for the first sales, which is a pizza event. So let's say super pizza Sunday. So I got a bunch of veggie, sausage, plain, and pepperoni. The second one is a Monday. So Monday night is pizza night. The third one is a Tuesday. Yummy pizza, yummy pizza. And so far, all the execution are running the pizza shop, right? Pizza sales, and you can see all these are typing in the pizza, 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 and the Wednesday, perfect pizza Wednesday. Pizza Wednesday. And now in the 5th cell, which is Thursday, it's a no pizza because from the 3rd one, from the 4th one, from the 5th one, we are using the regular superclass store sales daily bar chart. So no pizza Thursday. And it actually runs the superclass version. And 6 is regular TGI Friday. And Saturday, no pizza Saturday. So now you can see that the last 3 are defined as created using store sales bar chart. And the first 4 are created using the pizza sales bar chart, although the return value are all defined the same way. This one is actually a pizza sales bar chart object. So when run in runtime, each instance uses its own method. They can be defined the same way, but because internally they are different objects, so they behave differently. That's an example of polymorphism. And eventually we have this sales. I think generating the random number generation is not as good, although these are random numbers, but they all evened out. But anyway, I think that proves the point. How you define a method or instance can be different from what the instance it actually is. And this is called polymorphism.